Welcome back. I'm about halfway on the 200-mile drive. The car hasn't given any more trouble. It's the last couple of days. It's started beautifully. It's almost as if there is no issue at all. But I'm not going to get complacent. Yeah, I do know there is an issue, and it's probably nothing. Realistically, I was blaming the fuel pressure regulator. Realistically, it probably isn't. It's more likely to be dirty sort of connections or terminals. The car is 38 years old and it's very original. It's never been restored, and quite frankly, those plugs have probably never been pulled off, let alone cleaned. So I'm going to set about it early in the morning with contact cleaner. And I bought some very fine sort of brass and nylon brushes, contact cleaner, and also a pack of cheap nail files. And nail files are brilliant for sort of, rubbing the surface of the spade connectors. You can't really get wire inside them that easy. So I just trim them down with a pair of scissors, and you can poke the nail file inside. Just clean everything up, make really good contacts. Maybe give them a pinch with the plier. Just make sure that they're sort of biting quite hard. And I'll test for continuity of current, that sort of thing. But there's four components that could be at fault if the connections are all good. I've been blaming for the last couple of days. I've been blaming the fuel pressure regulator, but there's three other components, and I also suspect a possibility of an intermittent cold start injector. Quite often when the car's stood all night and it's cold, the first thing in the morning when you crank the engine over, it cranks for longer than is normal and would be expected for a car that's in such good condition mechanically and been so well serviced. It really should, within a second or so, just fire straight into life. And sometimes it's 3 or 4 churns on the starter motor. So there's a possibility the cold start injector is faulty or intermittent or blocked. It could be blocked. All the fuel injectors were cleaned and stripped and rebuilt. Now this cold start injector, it very well could be blocked. But they also have a bimetal strip inside, and they're thermostatically controlled. And it's very simple mechanism. You've got 2 strips of metal. They're different types of metal. They have a similar conductivity and electrical conductivity, but they expand and contract at differing rates. And these 2 strips are fine. They're riveted together. And obviously, as they expand and contract, it happens at different rates. So one of them will expand quicker than the other, and it forces the strip to bend. It either bends to the left or the right, and it makes an electrical connection when it bends. So if the connection or the contact, I beg your pardon is the word, if that's kind of dirty, if that's corroded, it's not going to make a good connection, if any connection at all. So if I can open it up, I'll clean it and file all the points. There's very similar with what did I say? That was the cold start injector. There is also an auxiliary air valve or an extra air valve, and that works in a very similar way. It's got a bimetal strip, and it just takes heat from it's the water jacket, I think, and it expands and contracts. So obviously when it's cold, it allows a little bit of extra air in. Likewise the cold start injector, when it's cold, it just allows a little bit more petrol in, but of course naturally it needs a little bit more air as well. So they both work off these bimetal strips, of which can you can have dirty contacts on the wires, but the actual bimetal strip contact could be dirty. So I'll be checking all this out tomorrow, and I'll try and do it on camera and let you see it in much more detail. And then there's another switch called a thermo time switch. This sits in the water in the water rail, and it measures the temperature of the water, and it sends a signal to the electronic control unit. And when it's cold, it just sends a little bit more. It enriches the mixture basically, just for a maximum of 8 seconds when it's really cold. And if the engine's slightly warm but not fully up to operating temperature, maybe it'll only operate for 3 seconds or 4 seconds, but it varies. And for a maximum of 8 seconds. And now that could be faulty, or but I'll go through all this tomorrow. I'll have all these pieces out and I'll test them. You can dismantle them, clean them, and dip them in warm water, dip them in cold water. And you can, with the thermotime switch, by dipping it in warm water, and you can measure the resistance with a multimeter, and then dip it in cold and measure the resistance. And it's got a given ratio, a given range. And if it's within those given ranges, it's fine, it's working. But if it's way without out of range, it could be faulty. I hope not, because they're quite expensive. They're around about £300 sterling. And likewise, the other two components I mentioned, they're about 300. I do know that the thermotime switch is they're used on various Ferraris of the 1970s, 80s and 90s. So it's a very expensive component, and there's a lot of Ferrari owners out there been buying them up, and they're quite hard to come by. So I just jolly well hope mine's functioning and I can just clean it. But I'll do all this in the daylight, in the street tomorrow. And actually, it might take me 2 days to go through everything. I spend 3 or 4 hours tomorrow and 3 or 4 hours the day after. And thankfully the weather's nowhere near as cold. I've been, it's been on my list of jobs to do all the electrical connections and test everything and clean everything, but I had no intention of doing it in the ice and the cold. It's horrendous working outside, and it's intricate work. And when you're sort of working with tiny little connections and you've got frozen fingers because of the ice, it's close to impossible. So I don't think it'll be too cold tomorrow. So even though it might be intricate, I'll cope just fine. So there's a lot to look at, and I'll try and explain in a bit more detail, and I'll do each individual component, make separate films. And the other thing I need to look at is the relays. The relays have a contact inside them, and they have an a copper coil and a magnet, and you get like a ticking from a relay when it makes a connection. It clicks or ticks, and you can be mistaken when you hear it clicking for thinking, oh, that's clicking, it's working. But if it's got dirty points inside, it'll be making a very poor contact, and you'll be losing current if it makes any contact at all. So it very well might click, but you don't get any real contact. So you can open up relays, clean them, and file the just with a nail file the contacts. So I'll be doing that as well. It will take some time. I'd imagine 10 or 12 hours in total to go through all of the wires, every connection, every fuse, every relay, every component tested. It's quite some job, and I had no intention of doing it in January or February in the cold, but thankfully the weather's a little bit warmer now, so we should be fine. And the car's running beautifully, but it's just these little niggles, and it's just old, and once they've been done, it will last another 20 or 30 years before it gets dirty or fail again. So as I say to you, I'll just make individual films tomorrow, and over the next 2 or 3 days, and just each component I'll try and examine it on camera, and we'll have a really good close look at it and see exactly how it works and how it fits. And I'm sure we'll get to the bottom of what is the problem with this car, but it very well might be nothing more than just dirt, corrosion in the terminals, loose wire. I might not have to buy any components. Fingers crossed, because most of them are expensive. The only one that's less than £100 is the fuel pressure regulator. But we'll just test everything before I go buying any components.